Okay, Bismillah. Let's see what is this logarithm and why do we have to learn this. Okay, I'll be asking you some questions and then you have to respond accordingly. Acha, tell me if you have, for example, 2 raised to power x and that is equal to 8. Huh? So what is the value of x here?
3.
3. You knew this because you can write this 8 as 2 cube. Okay, so this is x basically here. This is x and this is 2 cube. So your x is equal to 3. Now, what if I ask you that instead of this 8, you have 2 raised to power x that is equal to 5. So what is this x now? Can you tell what is x?
No, sir.
Diagonal. Yeah. So this is where we need the logarithm. Okay. So the logarithm is basically used to find the powers. So now, like if you apply the log here, you can write it as there are many kinds of logs with different bases. So filhal, you just if you want to use your calculator, this is log 2 raised to power x that is equal to log 5. Like just to convince you, we can solve this equation here using the logarithms. So this is going to be log 2 raised to power x that is equal to 8. Now there is a rule you will be learning later that this log 2 raised to power x can be written as x log 2. Oh, sorry, there has to be log as well. Okay, so that is log 8. Okay, so this is going to be x is log 8 over log 2. Do you have the calculator right now?
No, sir.
You must have the calculator. Bring the calculator and then you tell me what is log 8 over log 2. Okay, so this is through the calculator, you have found that this is going to be x equal to 3. So this means the answer that you gave me mentally, it is the same that you have found using the using this logarithm. So here you must be convinced that the logarithm is basically used to find the powers. Okay, so now look at this. This equation, this exponential equation can be solved now. We can write it as x log 2 that is equal to log 5. So this is going to be x equal to log 5 over log 2. Now you use your calculator and tell me what is this log 5 over log 2. So this is
2.32192809.5.
2.32, correct, 3 significant figures. So you see that you have found a power, an exponent using the logarithm. Okay, we'll come back to this. Now let's learn some of the basic uh, rules or basic principles or the basic properties of the logarithms. Okay, first of all, we'll see that how to um, change an index form into a logarithmic form. Okay, and it's vice versa, a log index form into the logarithmic form. Okay.
Yes, sir.
Okay, now when you have 2 cube and that is equal to 8, or you have 5 square that is equal to 25, or you have 3 raised to power 4 that is equal to 81, or maybe you have let's say 2 raised to power minus 1 is half, which is going to be zero point 0.5. Okay? So the logarithmic forms for these are, this is written as log to the base 2 of 8 that is equal to 3. This will be written as log to the base 5 of 25 that is equal to 2. You will write this as log to the base 3 of 81 that is equal to 4. This is log to the base 2 of 0.5 that is equal to minus 1. Okay, and all these like this is a new notation for you. You must see that this is a log with the base 2, this is the log base 5, the log base 3. So the base of this exponent over here, this exponential form, that is going to be the base of this logarithmic form. Okay, and this whole logarithmic form, all of this logarithmic form, look at this, look at this. What are they equal to? What are they representing?
Powers.
The powers, okay? So this is going to again reinforce the concept that the logarithm is basically used to determine the powers, okay? Now, there are some basic rules over here that now you will learn that suppose if there is 2 raised to power 1 and that is equal to 2, or there is 3 raised to power 1 and that is equal to 3, or there is 5 raised to power 1 and that is equal to 5. So what will be the logarithmic form for this? That is going to be log to the base 2, 2, and that is
Log to the base 2
log
is equal to 1.
to
Ji
the
sir.
base 3, 3,
3.
that is equal to 1. This is log to the base 5, 5, that is equal to 1. Now, basically, you see this 2 raised to power 3 is equal to 8. This 5 raised to power 2 is equal to 25. So, similarly, 5 raised to power 1, that is equal to 5. So, we can
5.
rule over here that, for example, if you have log to the base a, so what should this be equal to? 1, है ना? Yeah. So this is a very famous rule of the logarithms that if you have this base and the mantissa they are same, so that is going to be equal to 1. Okay? Um, Hassan, can you tell me what is log to the base 7, 7?
1.
1. So that will be equal to 1. Okay? अच्छा इसके बाद the next thing is I just told you that there is a rule like when we started here when I was telling you this power is basically multiplied with this, so I can get onto that like over here. For example, you have log to the base 7 of 49. Okay, log to the base 7 of 49. Now this is basically that is going to be equal to 2. Okay,
2.
equal to 2. Achha, what if I just write with this? Would you mind that if I write with this log to the base 7, 7? Hmm? Because what is log to the base 7, 7? Look at this, that is 1. So 2 into 1 is the same thing. Yes?
Yes, sir.
Now, if you look at this, can I write this as log to the base 7 and 7 square?
Yes, sir, you
Yes.
can.
So this means log to the base 7, 7 square is 2 log to the base 7, 7. You see, mathematicians are very smart. So how do they develop the rules over here? Okay. So this means whenever you have like, a power, like this power is basically has been multiplied with the coefficient over here. So that is why log to the base 7, 7 square, that becomes 2 log to the base 7, 7. So these are really very beautiful rules over here, okay? So if you have, for example, log to the base a, b raised to power n, so you can write it as n log to the base a, b.
And A.
This power is switched to the to this coefficient over here.
Yes,
Okay?
sir.
So far we have discussed that if you have a raised to power n that is equal to b, that can be written as log to the base a of b that is equal to n. Then you have seen another rule here that if you have log to the base a, that is equal to 1. Okay. And you have just seen another rule over here, that if you have log to the base a b raised to power n, this can be written as n log to the base a b. Okay, before we go into some further rules of the logarithms, we should be knowing that what are the conditions for a logarithm to be defined. Okay, now look at this. Uh, if I think I'll cover this in another segment. Let me first like just tell you one more rule and conclude this session, because too many rules would confuse you. Okay. Now, so we you know that how to convert from the index notation into the logarithmic condition. You know why this log to the base a is 1, and you have seen that how this power is switched to the coefficient over here. Then there is
Yes.
one, just one more very interesting rule over here. Do you know what is 2 raised to power 0? That is 1.
Equals to 1.
Yeah. What is 3 raised per 0? That is equal to 1.
1.
What is 5 raised per 0? That is equal to 1.
1.
And what is a raised per 0? That is also equal to 1.
1.
Can you tell me the logarithmic form for this 2 raised per 0 equal to 1?
So log with the bottom 2 and 0, 1
Log
and
to the
2
base
power.
2 of 1, that is equal to 0. है ना? This can be written as log to the base 3 of 1, that is equal to 0. है ना? This is log to the base 5 of 1. So similarly, we can generalize this as that log to the base a of 1, that is equal to 0. Like if you find the log of 1 with any base, that will be equal to 0.
0.
Okay, so you see there are three very famous rules of logarithm. They are, I have just like written them down here. The first rule here, the second rule here, the third rule here. Okay, and this one is the fourth rule over here. Okay, let me just tell you one more rule, and then we can get into the rules where we can solve the equations. Just one more rule into this equation, into this video. That is, in what are the circumstances, what are the conditions when your logarithm is defined? Okay, now if you have a log the base a of b, then this log would be defined if your base is not equal to 1. The base should not be equal to 1. You know why this base should not be equal to 1? Let me tell you. Now, suppose you have 1 square that is equal to 1. What is the
1.
logarithmic form for this? That is obviously log to the base 1, 1, that is equal to 2. Okay? And what if you have 1 cube? That is also equal to 1. So this means log to the base 1, 1, that is equal to 3. Now this is clearly an ambiguous situation over here. You can prove that, okay, this means that 2 is equal to 3. Anna, can we say that 2
Yes.
and 3 are equal? So if you want to have a defined logarithm, then your base should not be equal to 1. Okay. Then secondly, your base should always be positive. Your base should always be positive. Now, if you see that, if you have, suppose y is equal to 2 raised to power x, you can check that its graph would be like this. Okay, if you have, for example, um, yeah, if you keep on increasing the value of x, the values of y would be increasing. Okay, like if I just show you a table here, this is x, this is y. When your x is 0, your y is 1. When your x is 1, your y is 2. When your x is 2, your y is 4. When your x is 3, your y is 8. And so on, this keeps on increasing. Now imagine instead of this, if you have an equation where you have y is equal to minus 2 raised to power x. Can you draw the graph for this y is equal to minus 2 raised to power x? Hmm?
No, sir.
We cannot draw its graph because there is no continuity in the values. Look at this. This is x, this is y. When you put x as 0, you have this as 1. When you put x as 1, you have y as minus 2. When you put x as 2, you have y equal to 4. When you have x as 3, your y is minus 8. So how can I have a smooth curve passing through the points? Like, look at this. This is 0 comma 1 over here. Then you have 1 comma minus 2 over here. This is 1. Okay, this is minus 2. Then for the 2, you have 4 over here. Okay, this is 1. This is going to be 4. And then when you have 3, there is you have. So how can I have a curve like, this is going to be something like this? Okay, so for the exponential equations and for the logarithms, okay, the rule is that the base should always be positive. The base
Yes,
should
sir.
be positive. Okay.
Positive.
Now, this B is basically what you get after applying the power onto any base. If you look at this curve again, this is y is equal to 2 raised per x. Can you have this curve passing through the y-axis and going downward, like, showing negative values? Can you have any power on this two that can give you a negative value of y? Is it possible?
Sir, power 0.
Yes. Tell me any power on 2 which can give you a negative value of y.
No, sir, there is no power.
Hmm?
Basically minus 1.
Okay, if you take minus 1, what is your y?
1.
Is that negative?
No.
No. Tell me any power which can give you a negative value of y. So this is like if you take minus 2, you will have 1 over 4. So in no way your y cannot be negative. You see, its logarithmic form would be, if you write this in the logarithmic form, that would be log to the base 2 of y, that is equal to x. So this means that this y cannot be negative. This y cannot be negative. So similarly here, this b should be positive if you have a defined logarithm. Okay, so you just reinforce these rules. In the next video, I'll be giving you some more rules and we shall be having some questions to practice them. Okay.
Yes, sir.